In this video, I'm going to review with you the basics of hands-on equations. In order to complete hands-on equations, what you will need is your hands-on equation balance mat, as well as your pieces. Now to start, you're only going to have your red die pieces and your blue pawn pieces. These represent positive numbers and positive x's. The dice that you should have are two low dice. They have the numbers 0 through 5. And then you have two higher die, and they have the digits 5 through 9. So you want to make sure that you have those, and you have your 8 pawns. The pawns represent your x's, your positive x's, and the numbers represent numbers. Your hands-on equations worksheets will start looking like this. The triangles represent the pawns, and your numbers here and the squares represent the die. So you're going to want to set this up on your board exactly as shown. So if we take a look at this problem, we have one pawn and a 2 on one side, and we have a 9 on the other side. You always want to face the numbers up, looking at you, so that you know exactly what numbers you are working with. Now, it's important to know what this equation says. It's really important to remember that our balance is flat, meaning whatever is on this side is equal to what is on this side. We are always trying to find the value of one pawn, or x. So what this problem says, and I want you to practice writing it, the pawn is x. In between an x and a die, there is an operation. It's always plus. 2. Our balance in the middle is equal. 9. So now this problem looks really simple. X plus 2 equals 9. Now I'm sure you can simply solve that. However, I want to go through the steps of solving it with your pieces. You ask yourself two questions when you're solving hands-on equations. The first, are there x's on both sides? Take a look. No, there's not. There's only an x on this side. So I can't do anything with those x's. The next question is, are there numbers on both sides? Well, there's a 2 here and a 9 here. So there are numbers on both sides. If the answer to that question is yes, what you are going to do is look at the smaller number and take it away. So now whatever I do to one side of our scale, I have to do to the other. So since I just took 2 away, my 9 is going to become a 7. I need to also take 2 away from that side. So now my equation reads x equals 7. So now I want to check. When I check, I go back and I take my x, my value of x, and I put it back into the original problem. This is my original problem. My value of x is 7. 7 plus 2 equals 9. Solve the left side. 9 equals 9. They check. As long as these numbers are the same, when I put my value of x back into the original equation, I know that my problem is correct. The solution to this problem is x equals 7, and my check is 9 equals 9. Here's the next problem we are going to solve. The first thing that I'm going to do is I'm going to write this in number and x form. You'll notice that there's 2 pawns on this side. Now I'm not going to write xx, I'm going to write 2x because there's 2 x's. Now I have that operation symbol in between our pawn or our x and our number. The middle of our balance shows that it's equal. Here we have 1x plus 10. So now this problem looks a little bit more complex. We are going to use our board in order to solve it. I'm going to set this up the exact same way. I have 2 x's on this side and a 4. I have 1 x on this side and a 10. Now when you make a 10, there are 2 ways you can set this problem up. You can use 2 numbers that add up to 10, or you can use the 10 side of your die. As numbers get bigger, for example, if this was a 15, you would have to use 2 die to make 15. It's very important you don't use a 1 and a 5, you use a 10 and a 5, so you don't get confused. This is only 10. So now I'm going to ask myself my first question. Are there pawns on both sides? Well, in this case, the answer is yes. There's 1 pawn on this side, 2 pawns on this side. So I can take the one that has less away, 1. Now, whatever I do to one side, I have to do to the other. So now I have to take 1 pawn away from the other side. Now this problem looks a little bit different and a little bit simpler. I'm going to write what the problem says now. X, my 1 pawn, the symbol in between, 4, 10. Now this looks a whole lot easier. Second question, do I have a number on both sides? Yes, I do. I have a 4 on this side, a 10 on this side. I can take the smaller number away. Now I need to take 4 away from this side, and it becomes a 6. So now my equation says x equals 6. Now it's very important that I check it to make sure that I got the correct answer. What do I do to check? I take what I got for x, my value, and I plug it back into the original equation. So now this is where students get stuck sometimes. In between this number and this x, it's kind of like another little invisible operation, but this time it's multiplication. Remember, you have 2 x's, you have 2 pawns. So you can multiply in order to know what that value is. So I'm going to do 2 times 6, my value of x, plus 4 equals, put in my value for x here, 6 plus 10. Now I solve. 2 times 6 is 12, plus 4. 6 plus 10 is 16. 12 plus 4 is 16. I got the same value, 16, on both sides, so it checks. If you get different numbers on both sides, you know that you got the incorrect value of x. So in this case, for my 2x plus 4 equals x plus 10, the value of x is 6, and my check is 16 equals 16. This is the next problem that we're going to try. This is how it's written out on the hands-on equation sheet. In the first few levels of hands-on equations, it will draw out the pictures for you, and then it won't do it anymore, and it will just tell you the equation. But I think it's really good practice to take what it has written here in picture form and practice writing it in an algebraic equation. So this is how you do that. Here I have 2 pawns. 2 pawns are 2 x's. Our operation in between, always addition, 5. The center of our balance is equal. On this side I have 3 x's. Our operation is always plus 1. So now this looks like a really tricky problem, but with the help of our balance and our pieces, it's going to be a piece of cake. So first we'll put on our 2 pawn pieces, plus 5 equals 3 pawn pieces, plus 1. Now they look the same. First question I ask myself, are there x's on both sides? Yes, there are. We have 2 on this side and 3 on this side. We will always want to go to the side that has less. We can take 2 away from this side. Take them away. Whatever we do to one side, we have to do to the other. So I have to take 2 away from this side. Now I can rewrite this problem. 5 equals 1 pawn x plus 1. You don't have to do this middle stage of writing the problem, but I do think it's good practice when you start to wean yourself away from using the pieces and you just do the problems by hand. Second question, are there numbers on both sides? Yes, 1 on this side, 5 on this side. What number is less? 1. I can take that 1 away from this side. Have to take 1 away from this side. So what does it become? That's a big dice. A 4. Now my equation says 4 equals x. So now we need to check that. We can't always be sure that we did it correctly. In order to check, we take our value of x, we put it into our original equation. Again, if you have two x's, that's multiplying. You're multiplying 2 by the value of x. So we're going to do 2 times 4 plus 5 equals, same thing over here. Now we have 3 x's. So we do 3 times our value of x, 4, plus 1. 2 times 4 is 8, plus 5 equals 3 times 4 is 12, plus 1. 8 plus 5 is 13, 12 plus 1 is 13. It is really important just to avoid any silly mistakes that you write this middle step. So you may know in your head 2 times 4 plus 5 is 13, but it's really important that you write out each number in order to, if you make a mistake, you can easily go back and catch where you made that mistake. So here I have 13 equals 13. It checks out. So my equation, 2x plus 5 equals 3x plus 1, I solve for my value of x of 4, and my check is 13 equals 13. This time we're going to solve the problem from algebraic equation form. So this time your instruction sheet isn't going to give you the pictures to go along with it. It's just giving you your numbers and your x's out in algebraic form. So you're going to set it up the same way. Don't let it confuse you that the pictures are no longer there. Here you have 2 x's. Our x's are pawns, so we need 2 pawns plus 2. I'm going to put a 2 over here. Equals in the middle. 1 pawn plus 5. So now they read the same. First question, are there pawns on both sides? Yes, there are. 1 here, 2 here. How many can I take away? I can only take away 1 from this side, so I can only take 1 away from this side. I can rewrite this equation. X plus 2 equals 5. Is there a number on both sides? Yep, 2 and 5. I can take 2 away from this side. Whatever I do to one to keep that balance, I must do to the other. Took 2 away from the left side, so I have to take 2 away from the right side, turning my 5 into a 3. Now my equation reads x equals 3. Time to check. Take that value of x, plug it into the original equation. I have 2 x's, so I have to do 2 times my value of x, 3. Or if it helps, if you think about it like a repeated addition, you have 2 x's, you can think 3 plus 3. Whatever makes it easier for you. Plus 2 equals value of x plus 5. 3 plus 2 is 6. Three plus 5 is 8. That does not look like an addition sign, but it was meant to be. 2 plus 6, or 6 plus 2 is 8, equals 8. So it checks out. So for my problem, 2x plus 2 equals x plus 5. Got 3 for my value of x, plugged it back into my equation. My check, 8 equals 8. For this next problem, I'm going to ask you to complete the problem. Here I have x plus 4 equals 2x plus 3. I want you to pause the video, try to solve it, and then I'll work through the answer and you can check to see if you got the correct answer. Make sure that you bring it all the way through to your check. Your board setup should look like this. So we have our x plus 4 equals 2x's plus 3. First question, are there x's on both sides? 1 on the left, 2 on the right. I can take 1 away from each side. Now my problem reads 4 equals x plus 3. Next question, are there numbers on both sides? 3 on the right, 4 on the right, 4 on the left. 3 is the smaller number. I can only take 3 away from the right side. I have to take 3 away from my left side as well. So my 4 becomes a 1. Now my answer is 1 equals x. Now in order to do my check, I take my value of x, I plug it back into my original equation. Wherever there's an x, I'm going to replace it with a 1. 1 plus 4 equals 2 times 1, remember that little invisible multiplication symbol, plus 3. 1 plus 4 is 5. 2 times 1 is 2, plus 3. 5 equals 5. Check. My value of x for x plus 4 equals 2x plus 3 is 1. When I plugged it back into my original equation to check, I got 5 equals 5. Hopefully you got the same. Hands-on equations is a really simple way to introduce you to algebra as long as you follow the steps and you remember one very important rule. The first question you ask yourself when solving a problem, is there an x on both sides? If the answer is yes, you can take away the smaller amount from each side. Second question, is there numbers on both sides? If the answer is yes, you're going to take away the smaller number from both sides. Those go hand in hand with what the number one rule of hands-on equations is. Whatever you do to one side, you must do to the other. Remember, that balance is flat. It's equal, okay? If you have 5 apples on one side, 5 apples on the other, take away 1 apple on this side, you have to take away 1 apple on this side in order to keep that balance. As long as you remember those simple rules and steps, hands-on equations should be no problem.